Okay. Well, good afternoon, everybody. Hopefully everybody can see my screen. Just let me know if you can't. Randy, are you seeing it?
Yes, we're good to go.
Excellent. Awesome. Well, as Randy mentioned, my name is Matt Coates. I'm the Deputy Director in the Office of University Programs. It's an office within the Science and Technology Directorate in the Department of Homeland Security. And we have the pleasure of working with the Centers of Excellence through a variety of different mechanisms. I'll kind of walk through those today and how we're thinking about protecting the nation's critical infrastructure. So a couple of things I wanted to touch on just real quick, just to let you know through the agenda here. I want to talk a little bit about how I'm thinking about the critical infrastructure market, get into the 16 critical infrastructure sectors. For those of you that are familiar with this, this should be an overview, but I do think this important piece to highlight is it does impact how we think about it, the types of programs that we fund, and ultimately how relevant we are. I'll obviously talk about the DHS org chart just real quick to give everybody an overview of some of the assets and programs that I'll be mentioning. Talk a good amount about the Critical Infrastructure Security Resilience R&D plan that was developed in 2015 in collaboration with a few other departments, including Commerce. I'll talk about one of our other headquarters level elements, National Protection Programs Directorate. So these are our primary partners as we conduct R&D in pursuit of next-gen capabilities. Our MPPD colleagues are key and really lead the department's efforts in this space. I'll kind of start to wrap up with what we do in the Office of University Programs, how we do it, and then provide an overview of CIRI, obviously the Critical Infrastructure Resilience Institute, which is one of the department's centers of excellence.
Hey, Matt.
Yeah.
Let me interrupt. I'm sorry. I want to make sure that everyone is reading you loud and clear here. I got an indication that someone was getting the screen, but not audio. So.
Hear you loud and clear on my end.
Okay. Thank you, General. Anybody else? Guanyan, can you hear fine? Oops.
Randy, should I continue or do you want me to hold?
Let me see if I can. On my screen, I'm showing General Hayes. You said you got it loud and clear.
Yeah, I can see everything. Hear you very loud.
Okay. Gina Ton, can you hear the audio?
Yes, I can hear fine.
Okay, fine. Thanks. Go ahead, Matt. Let's press on.
Okay, no problem at all.
Sorry.
So for those of you, many PIs that are on the webinar saw some of these slides at the Critical Infrastructure Resilience Institute's first PI meeting. So it'll be a little bit of an overview, but hopefully this gives you a second chance to either ask questions or just kind of soak it in. So one of the things that we look at when we're developing technologies here in DHS is we have to understand really what those market conditions, what those market forces are, because ultimately, you know, the DHS components, they may be a customer, right? So they may procure a lot of the tools and technologies that are being developed not only in the centers, but through our other programs, but they're not the only ones. And so we have to be cognizant of what those different market drivers are, because ultimately it could impact things like the cost of tools. So the greater the utility, the greater the customer number of customers, you can all of a sudden start to see different business models emerge. So one of the things we really try to do is pay attention to these different market drivers. So for example, when we start to look at things like the critical infrastructure market, which is a really hot topic of late, you've seen a lot of different news reports that talk about aging infrastructure. You see a lot of discussion on various evolving threat environments. We had a pretty nasty hurricane season here. So you can start to see how these different markets are trying to deploy new technologies. One area that we're starting to really take a hard look at is how these infrastructures are relying on cyber assets as a way to either minimize risk, gain efficiencies, or otherwise just optimize and stay competitive. And so with the introduction of a lot of these new IoT devices and other methodologies, to gain these efficiencies, you're starting to see a huge increase in expenditures. And so on this slide, it's a cool little graphic, but it shows one of the things that we're looking at is a huge growth from 2016 to 21, from an estimated $7 billion to $131 billion as a potential market size. We're seeing, obviously, a huge uptick in IT spending, and this is expected. For those of you that are paying attention to a lot of the various cyber attacks, you're familiar with how that can impact a company's bottom line. We're looking at businesses trying to get smarter about how they make decisions on build or buy. So there's a lot of outsourcing of some of the IT system expertise to companies that have core competence in this area. The bottom section here talks about the number of devices that are being connected. There was an explosion in what I would refer to as the consumer IoT device world. 20 billion devices connected by 2020 really can start to change, if it obviously already has, the threat landscape and how different devices that formerly were never connected are eventually connected, and how that could potentially lead to some different vulnerabilities. We're looking in major changes, obviously within the government, but we're looking at transportation, so airports, airlines, oil and natural gas, and some other things. So this is a huge movement the department is obviously very aware of, and I wanted to just kind of highlight this as a level set for the rest of the presentation. When we kind of boil it down into it, the department's not really interested in competing on development of IoT devices, but we are looking, not only are we consumers, but we're also looking at some of the regulations and some of the risks posed by potentially new vulnerabilities that are created with these connections. So obviously, if you look at like the cybersecurity market, for example, we have another huge growth curve. Really, in a 9-year period, you're looking at a doubling up to $114 billion, with you see a compound annual growth rate of nearly 10%. And this is huge growth. This is a very fast-moving environment in which obviously the government, who traditionally funds earlier stage R&D or really doesn't really get too much outside of the Department of Defense into applied work. This is something that we have our finger on the pulse for because of the fast-moving pace, and we want to be able to contribute to the responsible shaping of what this future might hold. I had mentioned earlier that the airport, oil, gas, banking, and government segments are really the primary drivers of this 10% annual growth rate. You can see, obviously, on the bottom, some of these just visualizations that demonstrate kind of how we track this. This is from Frost & Sullivan, one of the market research sources that we use to kind of inform some of our program planning activities. We're also seeing a bigger increase in the partnerships between kind of traditional IT, cybersecurity firms, and to some extent operational technology developers, which I think is a good thing. And hopefully we can continue to formulate the partnerships necessary to make sure that those folks are informed as they're making next-gen investments. So I'm going to kind of switch now into the second topic and just remind everybody of the 16 critical infrastructure sectors. I've kind of separated them out here into the sector-specific agency, the sectors that DHS is the sector-specific agency, and those that are not. I think this is pretty important because in the Science and Technology Directorate, we receive a lot of inquiries about, different technology approaches or proposals that folks are interested in. And although we have a pretty active role in the non-DHS column there with, for example, food and agriculture, we have tremendous partnerships, but at the end of the day, we're not a regulatory agency, right? And so this changes the relationship that we have with the vendors that are building tools for those agencies. And so we maintain awareness, and we do have some active programs. But the reality is for this particular center, what we were trying to concentrate on is those sectors that we have real strong purview over. You can see them on the left, and when we start talking about the CIRI research agenda and some of the thematic areas and stressors, hopefully you'll see why and how we're incorporating that knowledge about those sectors into the actual work plan of the center. So I showed this at the CIRI annual PI meeting. The point of this slide is really to talk about the diversity of research entities and businesses that are operating, programs, R&D, tech development programs in the world of resilience. So, given what I was talking about in the beginning, the reality is there's so many different entities that are aware of the trends, that want to have some new partnerships, or just want to kind of stay ahead of the curve. And so what happens with this is it almost becomes very difficult to craft a research portfolio of projects that's not either duplicative or that effectively starts to pull you out of your strategic vision. And so with this absolute, I don't want to say mess, but aggregation of research entities, it becomes really tough for the department to select which projects are going to be most meaningful, which programs we want to fund. So when we talk about resilience, are we talking about cyber threats, natural hazards? What infrastructures are we talking about, per my last slide? It becomes really, really difficult. Since 2013, just on the federal side alone, over 150 large research grants have been issued related to critical infrastructure resilience. So it puts a lot of responsibility on my office and those in the Science and Technology Directorate, to really do your homework as you're trying to select some of these projects. It also puts the onus on the researchers to make sure that they're aware of complementary approaches, stuff that's already been done, potential leverage points that can be used, for example, in modeling or data analytics. And we look for this in a lot of our proposals to make sure that those that we fund, can demonstrate that they have that knowledge. Within the Department of Homeland Security, so this is your kind of typical boring org chart, but it is important. I had mentioned National Protection Programs Directorate earlier. Science and Technology Directorate, so that top bar is a headquarters level bar. That's where my office sits, and we're responsible for providing not only the R&D, but a lot of the technical guidance, to the operational components and other headquarters elements. So we have an appropriated budget. I'll get into that later. But we're working with NPPD in the execution of some of these strategic initiatives that they have, which I'll talk about in a little bit. As part of the CIRI research portfolio, one of the things we took a look at is who is owning a lot within the government, a lot of these infrastructure assets, right? So a vast majority of stuff is owned by the private sector, but the government is also obviously a big player in this space, as we have our responsibility over our own facilities, we have a responsibility over our own IT systems and so forth. So we've made a couple strategic partnerships with FEMA on the bottom there, U.S. Coast Guard, and for this center to some extent Customs and Border Protection in the form of positioning for next-gen mobile devices. So as we start to talk about who our customers are, those are the ones that I wanted to flag. Obviously, infrastructure owners and operators at large, are a primary market, to include, states and to the extent possible, locals. But within DHS, I think it's important to highlight the fact that I'm really, really interested in making sure that our tools and technologies are geared and relevant to these groups. So one of the driving things behind, how we think about funding R&D is this 2015 Critical Infrastructure Security Resilience R&D Plan. So this was done in response to Presidential Policy Directive 21 and Executive Order 13636, you can see here. And what it really does is it requires DHS to provide this plan, take into account the different threats, figure out how we're going to evaluate progress against this, and then make adjustments accordingly. So there's a couple of very high-level R&D topic areas that it recommends, And so we try to implement this in our own programs here in the Office of University Programs, and specifically with the CIRI group here. So you can kind of, I won't read through them, but I mean, obviously working with the university consortiums and their partners, the core competency in our academic partners is absolutely understanding the early stage R&D. We're not NSF. We do fund a lot and strive to fund a lot of applied research. But I still look at that as developing that foundational understanding of how these systems are interconnected, how they actually work. The next thing, too, that they talk about in the plan is making sure that as a risk-based organization that we're thinking about and developing methodologies to assess risk at the various levels, so at the micro all the way up to the macro level. And this is really, really hard when you're trying to integrate risks across a variety of scientific domains, spatial and temporal domains, as many organizations typically just do risk assessments, you know, I'll say the local level, meaning the micro level. Situational awareness has been a long-standing kind of a tough point, as inherently with the Department of Homeland Security, not everybody can has the need to know in terms of true threat information, but to the extent possible, understanding data governance models and how do you apply different data analytics to create generally a unified picture that actually confers some value, you know, to those folks that are providing that data, so that they can take countermeasures or responsive actions or make wise choices in countermeasure deployment. And then obviously the last one is building a cross-culture in R&D collaboration, which hopefully through the center we actually achieved that. So within the National Protection and Programs Directorate, when we start to look at how do we operationalize some of these guidance principles from the documents and the executive orders and presidential policy directives. So NPPD runs a couple of, I'm just highlighting just two here, a couple of offices that have real primary jurisdiction in this area. So the Office of Cyber and Infrastructure Analysis, otherwise known as OCIA, you know, this group really is the internal kind of a think tank, if you will, that's providing a lot of the analysis to guide policy. So they are one of the research entities that the department can look at, you know, for advanced modeling, for different data analytics. They've done quite a bit of work across different kind of threat spaces to include hurricane storms, floods, some cyber modeling and simulation, and they do provide support to the Regional Resilience Assessment Program that if those of you on the phone that aren't familiar, is basically a program that allows localities to submit, based off of risk assessment information, you know, requests to study particular problems that are appropriate for that geographical region. Our colleagues in the Office of Cybersecurity and Communications, CS&C, they lead I would call them, they are as close to operationally focused as you could be as part of a headquarters level element. So this is where our U.S. CERT folks are, a lot of voluntary programs to try to understand when different infrastructure owners and operators have been compromised. They have primary responsibility, obviously, in the cyber and communications infrastructure. And very importantly, they lead the federal government's effort by protecting the .gov domain for the civilian agencies. So I'll go back a little bit to the directorate that I sit in too. So because we serve those components, including FEMA and TSA and Coast Guard, you know, our portfolio of investments is generally pretty broad. We cover a lot of different challenge areas and operational environments. But my office in particular is pretty unique within the directorate. We're kind of a microcosm of a lot of these different topical areas. So we're enacted in the Homeland Security Act of 2012, and really what that act does is it establishes our office to go out and get some of the best and brightest from the academic, from industry, to form consortiums that really start to push ideas up to the department. And you know, this is it's been a fantastically productive program. Some recent highlights, return on investment from GAO were quite impressive. If you, for those of you that follow any of those reports that talk, I think of the most recent one was we had a project that was $600,000 investment that GAO identified as having an ROI of $290 million, over a multi-year period. But really, the Act guides us to create these relationships, to create basically the environment for these centers to succeed. So that's what my primary job is. Here's kind of a boilerplate slide. So one of the things that we really do is we set up these centers, right? Everything is really competitive. For those of you that have followed our solicitations or have applied, it's a very rigorous process. But basically, once you're nominated, once you're part of the center, these things evolve over time as the threats evolve. And the program managers here really work with the components to try to interface to make sure that the research projects that are selected, remain relevant, that potentially get the data that they may need, although that continues to be, one of the challenges. But ultimately, that the information that's generated out of our R&D is actually useful. And this is really tough with us being an operational agency and partnering with the academics. A lot of times, the valley of death, it might be a little bit too far to bridge. And so a lot of our processes and procedures are set up to try to minimize that valley of death, if you will, and to ensure that folks can get some use out of the work. In doing this, obviously, those of you that have worked with the government, one of the primary jobs that we have is really moving money, and it's trying to figure out how to move money towards wise investments. So this has been a big push for us in terms of new process development. But as part of that, too, and in the execution of the programs, given what I was talking about in the beginning with the understanding the market forces, we work with the centers really to establish kind of a risk tolerance of how risky do we want to make our investments in terms of next-gen technologies. How is it that we can really get those researchers to understand the operational problems? So we look at doing IPAs to try to embed students, in the components where appropriate to really learn and bridge the world of academia and operational use. And this is tough, very different model from NSF. Part of our mission set within university programs is to train, the current workforce, but also next-gen, student development. And in the world of cybersecurity and computer science, there's not a lot of need as the market really can pull, and there's a lot of great job opportunities out there. But figuring out unique ways in internships, co-ops, things like that, to be able to turn students on to the potential application of their, traditional academic teachings to something that's useful to the department. I mean, that's front and center. The department runs a Homeland Security Academic Advisory Council made up of 10 to 12 academic presidents to try to figure out ways to increase the uptake, the pipeline, if you will, of students into technical jobs within the department. So this is also kind of not a side mission, but works hand in hand with the primary focus of generating next-gen projects. As I mentioned, we have quite a few of the centers in very diverse areas where we actually maintain 10 centers of excellence, although this year we're cycling off some as a function of the end of the cooperative agreement. On the left, you see the topic areas that we've made these. These are directly tied to the long-standing missions of the department that are more or less not going to change. So we do get asked a lot of questions about, hey, can we have a center of excellence in a particular topic? And the reality is when resilience and critical infrastructure is so broad, you can get into a situation where you get a lot of ideas that are not necessarily well placed in terms of alignment to the particular mission. So I'm showing this slide to really try to make sure that people stay focused on the fact that we are Department of Homeland Security. We have these 5 core areas, and obviously we're looking for proposals that generally map to that. You see that the infrastructure protection resilience on the bottom, that's obviously where our CIRI friends and colleagues kind of sit. Definitely direct alignment to a few of the mission areas. A lot more information about our current centers of excellence are online at hsuniversityprograms.org. It's actually an org and not a .gov, just because it's run by the actual consortium of the centers themselves. So now jumping a little bit more into CIRI specifically. So obviously with the rapid expansion of a lot of information and communications technologies into industrial control systems, looking to gain efficiency, companies looking to gain efficiencies and things of that nature. As I talked about before, I mean, these are kind of some key things that we've been paying attention to. That threat space is potentially changing. Not everything is a threat or a vulnerability, but the reality is we don't have our finger on that pulse. It's kind of a challenge. One of the things, too, that we've been following is how humans are interacting and how they understand the complexities that are inherent as our infrastructures get more and more interdependent. And this is really hard, and it potentially, we think, requires obviously some computational and data analytics capabilities that may or may not exist right now. How humans are understanding and making choices based off the data they're seeing, can have a huge impact on lives, money, and just obviously general community resilience. And so how humans are evolving and understanding what this information means is something key that we try to make some investments in. So from that, we actually spent a good amount of time with our University of Illinois partners to try to hone in and figure out how to drop this money in an area that's going to make a difference. And so what we really did is we centered on 4 R&D themes that we thought that generally were going to be tried and true for several years, in which several projects and several future projects could fit into. And that's insurance and the business case for resilience. So there's a lot of different models out there, a lot of different entities that will talk about being able to do risk assessment. They can do modeling, but inherently infrastructure owners and operators, what we've seen is they really not necessarily struggled, but there hasn't been the uptake in the utilization, and there's a variety of reasons for that. Some of which are, the models inherently were built so that only the modelers themselves could use it, right? So it's kind of a built-in business case. Some of them are too complex, or some of them the uncertainty is unknown, or they're kind of a black box. There's a lot of different reasons. So we're trying to understand how people are interpreting them in the real world, and how different drivers like the insurance market could potentially reward those for making well-informed risk reduction measures. We wanted to look at the micro and macro supply chain itself. So both looking at specific nodes, so how industrial control systems are evolving over time, how different corporations are using new emerging technologies, at a local level. But then also what happens to supply chains at large. So looking at things like the U.S. port system, the capacity of that port system, how products move through commerce, things of that nature. Underlying this, we have a research team looking at infrastructure dependencies and interdependencies. This has been a hot topic for almost 2 decades. You can go back, there's been tons of work looking at trying to, how do you model the interactions of power, water, oil and natural gas, food and agriculture, healthcare, right? And so what we're looking for is some next-gen modeling techniques that allow for expansion across those infrastructures and really build on that work. And then finally, kind of more of a blue sky type of a mindset here in next-gen communication. Right? The idea is with a lot of these IoT devices, you get into a situation where basically as our telecommunications capabilities evolve, right, we start looking at things like 5G potentially, you're going to be able to transmit a lot of data over these networks. And so trying to understand how infrastructures are going to be affected by a potential transition from, your real traditional kind of laying the wires type of approach to more of a mobile device dominated world. We're trying to make some strategic investments in some things like test beds, for example, or pre-positioned mobile threats within the supply chain, both hardware and from software updates. You can see the portfolio of projects, or the breakdown of projects and how we've kind of made some investments there. I won't belabor that point. I talked a little bit about this. I'm going to actually kind of just skip this particular slide and kind of shift gears to the last part of the presentation here. So when we're doing a lot of the R&D in these research teams, one of the things I wanted to point out to those that are obviously part of the center know this or beginning to know this, and those that are interested, hopefully this will give you a little bit of a crash course. But there's a pretty big difference between research in technology and capability development. So when working with a department, it's really, really key to make sure that that folks are on the same page, that expectations are managed. So a lot of researchers like to do the research, but at the end of the day, it's pretty hard and it's not really realistic to think that an operator is going to spend time, reading journal articles. And so the reality is when we're looking at evolving technology over the time, we try to encourage the centers of excellence to create the capability to start to transfer, doing technology transfer or commercialization, start to move products from the lab into prototype status into the market. And so inherently, the composition of the performers within the center of excellence likely will change over time. So typically the trend is that we see that businesses get involved as technology looks to fairly promising as it hits its milestones and things of that nature. So the centers really are serving as more of a technology development asset than a traditional kind of NSF research model. This slide is not intended to be able to be that readable, but it more or less prove a point. So a lot of folks in the Department of Defense use technology readiness levels as a way to express the maturity of the technology at any given time. Right, it goes from TRL 1, technology readiness level 1, up to really 9, with 9 being a commercial grade product. And I think that the point here is it was what I was making earlier, is that when you engage with some federal customers like those in U.S. Coast Guard, for example, a lot of folks in procurement and acquisition, the program managers, I mean, they're kind of thinking more or less along this road. So when we start introducing and linking our researchers up, a lot of times what we have is initial concepts or theories. And so, what part of my job is to make sure that we have clear understanding of what the true status of the research is. Diving a little bit deeper into how we're constructing the center, so if you're a PI potentially thinking about putting in a proposal or engaging in some other way, one of the things that we ask the centers to do is figure out strategies to become sustainable over time. So obviously the department is providing a substantial amount of seed money, but we want them to be successful in the licensing of technologies and effectively form some sort of a intermediary between traditional academics and licensing shops, tech licensing shops. So part of this is really figuring out what is an appropriate mix of projects to really generate enough interest, revenue, and obviously value to customers to be sustainable. And so, decisions on projects that are really simply knowledge products, I mean, we have to ask tough questions about how does that actually contribute to long-term sustainability, of the center. It also helps in being clear with our components. So if there's an opportunity to really do direct licensing, of different software capabilities, we want to know that it's actually getting towards true commercial grade software, not necessarily some gradware, more or less. In terms of how we're thinking about commercialization, is not everything, but for those projects where commercialization makes sense, we do have some kind of mental models and frameworks that we use with the center to ask some tough questions that would really start to get at answers about how valuable is the pursuit of intellectual property and patents, copyrights. How likely is it that you would need an incumbent to be able to actually deliver on what the proposals say? So understanding those two basic questions, which sometimes aren't that easy, understanding what those are really points you into a particular strategy that we look for. And so there's no guarantees in the uncertain world of R&D, but we do try to minimize overall program risk by making sure that the centers are applying the appropriate strategy given the project in hand. I'm just going to close out here. I know that we end here at about 1 o'clock, but we do have a couple of upcoming events that I'd like to highlight. Obviously, November is, for those that don't know, I should say, is Critical Infrastructure Month. So there's a variety of events that are being put on, not just by the department, but by different organizations that have made pretty big investments in resilience. But specifically for us here at the Department of Homeland Security, we're doing a Facebook Tech Talk on the 9th. Our colleagues at CIRI are putting together a different webinar series on some technical topics to highlight some emerging research for those that are interested. We are doing a 12th to the 13th. It is invite only on a subset of artificial intelligence and quantum computing, how that may have applications in the Homeland Security world. So that one is not as public as some might think. And then internally, as a program review, I mean, we like to be transparent with public funds. We do review all of our centers on a biannual basis. These are very, very kind of intensive reviews that several of our projects that have been operating, from the 12 to 24 months we'll be going through. So any of those interested PIs that want to engage and partner up with CIRI and throw a proposal in the ring in the future, this is one of the things that we do to check, obviously, maintain scientific quality and relevance. So I think that's my last slide. I know that we're pretty close to the time there, but I really appreciate the opportunity to just kind of run through how I'm thinking about managing R&D in this kind of very large critical infrastructure resilience environment. I'm not the only one that does this. I have several colleagues, not only in S&T thinking about this, but obviously in NPPD and some of the components. So just really excited to be able to share some thoughts with you guys. And, Randy, I'll turn it back over to you.
Oh, thank you very much, Matt. Really appreciate it. Great presentation. Do you have any time? I know we're past the time frame, but do you have any time to take any questions? We have a number of people still on the line.
Yeah, absolutely.
Okay, those on the line, if you have any questions, please unmute yourself and ask Matt the questions that you might have.
Well, that's nice and easy. Randy, one maybe last plug for those that are interested in some of those documents. They're all publicly available, like the research R&D plan that I kind of really quickly breezed through. There's a lot of good information just on the risk assessment and the management approaches. Gets into a little bit more detail than I was able to do in the short time here. But I would point you to those as kind of a guidance document, as you're kind of formulating your teams and ideas for the future.
Good. Understood. Okay, not hearing any questions. Why don't we go ahead and close that out? Again, thank you very much. Those on the line, we do have on December 6th at 1 p.m. Our colleagues at the University of Pennsylvania's Wharton School will be conducting our next webinar series, and we'll be discussing issues associated with identifying and reducing the barriers to infrastructure insurance. So stay tuned for that, and we look forward to that presentation on the 6th of December. Thanks again, Matt. Appreciate it very much. Thanks all.
Great, thank you.